Okay, we're now going to talk about multiplying radical expressions. Now, we've done that already, but they're talking about something with a little more complexity to it. So let's look at this first example. We're going to take the radical square root of 5, and we're going to multiply it by, in parentheses, 4 minus the square root of 20. Now, don't let this fool you. You've seen things exactly like this, because if I gave you 3 times 4 minus x, you would use distributive property like you always do and not think twice about it. And that's exactly what you need to do here. You just need to use your skills with distributive property, just like you've always done. So, square root of 5 times 4 is 4 square root of 5. You always put the number in front and the radical second. And then minus, and then we're going to multiply square root of 5 times square root of 20. Now we know from part 1 of this lesson, the square root of 5 times square root of 20, because of the product property of radicals, can be combined. So we've done our distributive property, and now we're going to use that property. We're going to leave 4 square root of 5 as is, and combine 5 times 20 inside the radical, and make that the square root of 100. Well, we know the square root of 100 is 10, so we have 4 square root of 5 minus 10. And that cannot be simplified any further, so we have to leave that as is. Let's try another similar example. What if I had the square root of 3 times 2 plus square root of 12? I really strongly recommend that you pause the video and try this out and see if you get the right answer. Just take the same steps that I just did above and see if you know how to do this. Just as I mentioned before, we're going to do our distributive property. So square root of 3 times 2, and then square root of 3 times the square root of 12. Well, square root of 3 times 2 gives us 2 square root of 3. Square root of 3 times 12 gives us, I'm not going to jump the gun. I'm just going to write it down as I did above. 2 square root of 3. The square root of 3 times the square root of 12 is going to give us the square root of 36. Square root of 36 we know is 6. And we still leave the 2 square root of 3 as is. So we end up with 2 square root of 3 plus 6. Let's look at one more example. And in this example, we are going to do something you've done before, but it's going to look a little different. I'm just going to draw a line here so that everything is separate and we don't confuse matters too much. Let's look at square root of 7 plus the square root of 2 times square root of 7 minus 3 square root of 2. Again, if this said a plus b times a minus 3b, you would say to yourself, oh, I am just going to use FOIL, right? First, outer, inner, last. And that's all that we need to do here. We're going to use FOIL. So FOIL means first, square root of 7 times square root of 7. So square root of 7 squared, right? That's first. Next, I'm going to do outer. Well, that's square root of 7 times negative 3 square root of 2. So, plus square root of 7 times negative 3 square root of 2. Now I'm going to do inner. I'll just put that up here. And it's the square root of 2 times the square root of 7. And then finally we have last. Let's see how I can fit this one in. These two here. The square root of 2 times negative 3 square root of 2. Just fit it. Okay, well, I've now written everything out, and I need to use all the skills I've learned during this chapter to simplify this. So, square root of 7 squared. Well, we know that the square root and the square undo each other, so we're left with just 7. Then I have the square root of 7 times negative 3 times square root of 2. Well, I have two radicals, square root of 7 times square root of 2, and those can be combined. So the negative 3 stays outside, but I get negative 3 square root of 14. Then I have square root of 2 times the square root of 7. Well, that also becomes the square root of 14. And then last, I have the square root of 2 times negative 3 times the square root of 2. Well, the square root of 2 times the square root of 2 is going to give me the square root of 4. So from this, I'm going to get 2 times negative 3. Let me draw this so it's a little neater. Again, the reason I'm getting 2 is I've got the square root of 2 times the square root of 2, correct? So square root of 2 squared, just like the square root of 7 squared here. So because I get the square root of 2 squared, the result is going to be just 2, because it's the square root of 2 squared is square root of 4, and square root of 4 is 2. But it's still multiplied by negative 3. So I put an extra step because I want to make sure that you see where this number is coming from. So 7 plus negative 3 square root of 14 plus square root of 14 plus negative 6. Well, I'm down to my last step where I have to combine like terms. Well, 7 and negative 6 are a like term. And so I combine 7, negative 6, and I get 1. But I do have like terms here. I have a negative 3 square root of 14, and I have just a square root of 14. And I can combine those, and this will give me negative 2 square root of 14. And that is the answer to my problem. 1 minus 2 square root of 14. So I'd like you to go ahead right now and do guided practice number 7, which is the last problem we have to do before we do our real world problem or our word problem. Okay, guided practice number 7. We're going to simplify the expression 4 minus the square root of 5 and 1 minus the square root of 5. So as I demonstrated before, we're just going to use FOIL to solve this. So first is 4 times 1 is 4. Outer is 4 times square root of 5, so 4 square root of 5. Inner is negative square root of 5 times 1, so minus square root of 5. And then last is negative square root of 5 times negative square root of 5, and I'm going to get a positive 5, right? Because it's the negative square root of 5 squared, and that's going to give me a positive 5. If you're not sure, here I'll just demonstrate it. Negative square root of 5 times negative square root of 5 is the same as negative square root of 5 squared. Okay, that's just so that you understand why I'm getting 5. That's from this. Okay, well, combining like terms, I get 4 plus 5 is 9. And 4 square root of 5 minus square root of 5, those are my like terms, plus 3 square root of 5. And that's going to be, let's see, not square root of 5. Make sure I did that correctly. First, outer minus, aha, I made a mistake. My outer is negative 4 square root of 5. I hope some of you guys caught that. And this means negative 4 square root of 5 minus square root of 5 is going to be negative 5 square root of 5. So let me rewrite it properly. 9 minus 5 square root of 5. In case you're wondering about why I went back, when I first wrote my FOIL, I have first, that's 4, outer, 4 times negative 5, that's negative 4 square root of 5. Inner, negative square root of 5. And last, which is negative square root of 5 times negative square root of 5. Okay, so that is our answer to guided practice 7. And then last, I'm going to do example 7. Okay, now this is an astronomy problem. They're talking about the orbital period of a planet, and that's the time that it takes a planet to travel around the sun. So the drawings in the picture, here's the sun, and they're talking about Jupiter, so here's Jupiter. That's the distance, and here's the sun. And the orbital period of a planet is how long it takes it to go around the sun. And that orbital period, P, can be found using this formula. P equals the square root of the diameter, or the average distance, not diameter, sorry, average distance in astronomical units cubed. So this is called, just so that we know everything that we're talking about, the period of orbit, and this is in Earth years, because that's the only kind of years we really understand. And D is the average distance of the planet from the sun. Average because it's an elliptical orbit, right? Not circular. And the units for that is called astronomical units, AU. Okay, so here's our equation. Now, if you'll look at the drawing, they added a label to the distance that they're calling 5.2 AU. So this distance here from Jupiter to the sun is 5.2 astronomical units. So the first question they're going to ask you is, can you simplify the formula? Okay, simplify. Well, if I have P equals square root of D cubed, I know because of my product property of radicals that this can be separated into 2 square root of D times square root of D squared. And I know that square root of D squared is just D. So my period P equals D square root of D. All right, I've simplified my formula. Part B. Jupiter's average distance from the sun is shown in the diagram, which shows 5.2 astronomical units. What is Jupiter's orbital period? Well, if I have P equals, now my simplified formula, D square root of D, it equals 5.2 times square root of 5.2. And when I work that out, it is approximately 11.9, and we know that periods are measured in Earth years. In other words, it takes Jupiter about 11.9 Earth years to go around the sun. Okay, well that's it for 11.2, and tomorrow we're going to start 11.3, and it will be due the first week after the vacation.